Hello students, you're most welcome once again in chapter 10. This is the lecture 2 and the remaining portion of reflection will continue and will complete today. So in this module, you'll learn about the sign convention and some numerical questions about the reflection of light. That means sign convention of mirrors, spherical mirrors, concave mirror and convex mirror. Points to be remembered as we discussed last topic mirror formula, and after understanding the mirror formula, so we'll go ahead, and the height of the object is taken as positive as the object is usually placed above the principal axis. So in case of whenever we are taking the height of object, we used to take positive because it comes above the principal axis. Height of the image should be taken as positive for virtual images because virtual images forms above the principal axis. However, it is to be taken as negative for real images because they forms under the principal. When the image is real, it is inverted. So H2 is negative as we discussed last formula, and which results M is negative. That means we are talking about the magnification. That means magnification will be negative for all real images. It should be remembered by all you, whatever with the that means it can be lens or mirror, it doesn't matter. But if you are finding real image will produce negative magnification. Okay. A negative sign is in the value of magnification indicates that the image is real. Okay, negative sign will indicate, that means negative sign doesn't mean that means it is less than zero. Negative sign will say that it is real image. Okay, and second, when the image is virtual, it is erect. So H2 is positive and result M is positive. Okay, which result M is positive. So it means if value of magnification is positive, that means it will show images virtual. So now we'll see the sign convention. A sign convention for spherical mirrors. First point is there, object is always placed to the left of the mirror. That means suppose this is the mirror and we used to place the object always left side of the mirror. All the distances are measured from the pole of the mirror. See, we are observing pole is here. See, this is the pole. So we used to find out all the distances from this point. That means the point of measurement. That means from this point we used to measure all the distances. Distance measured in the direction of the incident ray. That means incident ray. That means this is the direction of incident ray. And if we are measuring any distance in this direction, will be positive. So in direction of incident ray are positive, and distances measured in the direction opposite to that of incident ray are negative. That means suppose we are measuring in this direction, so it is the opposite direction of incident ray, so distances will be negative. Okay, distances measured above the principal axis are positive and below the principal axis are negative as we discussed. So see, I hope you understood. So in this direction all the distances will be negative, and in this direction all the distances will be positive, and in below the principal axis we will take all the negative distances, and above the principal axis in upward direction always we will take positive sign for the distances. I hope you understood these all concept of the distance measurement or sign convention for the spherical mirror. This sign convention will be applicable for all spherical mirror as well as for all lenses also. Okay, so sign convention, I hope you understood well. Again, we'll see that the distances measured in opposite direction of incident ray, that means in this direction negative, and distances measured in the same direction of incident ray, that means in this direction positive. Okay, and above the principal axis positive and below the principal axis negative. I hope you understood well. The next thing will come. So we are taking some questions so that you can understand well. See, find the focal length of convex mirror whose radius of curvature is 32. We are knowing the relationship between focal length and radius of curvature. So half of the radius of curvature is focal length. So 32 is there. So what will come? 16 is the focal length of convex mirror. and concave mirror produces 3 times magnified enlarged image, real image. See, it is we clearly mentioned real image of an object placed at distance of 10 centimeter in front of it. Where is the image located? So what we are observing the 3 times. That means it says that means image is 3 times larger than the object. Magnification will be 3, but here they are saying that real, so we'll put negative sign. You always we take negative because it is placed left side of the mirror. So we want to know. So we know formula m is equals to minus p upon u. I place the value of m minus 3 and minus sign and minus this minus sign to cancel this minus sign and 3 30. So position of the image. So it says that means in front of concave mirror. So see, this is the concave mirror. It says that the image will be 30 centimeter in front of the mirror because negative sign saying image will be forming in front of the concave mirror. I hope you understood this much. Now some questions are there, so you can see these questions, and just by that means with the help of sign convention and all mirror formula, you can solve some questions. I'll solve some questions on next page. Just see the questions by stopping the video when you are seeing. You can solve some questions. I'll give some solutions so that you can understand well. I think reflection of light was easy. I hope you're understanding. So see, first question is saying find the focal length of convex mirror of radius of curvature is 1 meter. So what we are knowing radius of curvature. So half of the radius of curvature will be focal length. So focal length of this question will be what will come 0.5 meter or 50 centimeter. I hope you understood this question. First question. Second question also very easy. They are saying that focal length of mirror is 50 centimeter and radius of curvature. So double of focal length will be radius of curvature. So it will 100 centimeter or we can say 1 meter. And radius of curvature of concave mirror is 25 centimeter. What is the focal length? So again the radius of curvature is given 25 centimeter. So focal length will be 12.5 centimeter half. I hope you are understanding this. This is the very easy relationship. And next, a concave mirror produces 10 centimeter long image of an object of height 2 centimeter. See, this is the height of the image and this is the height of the object. Now, what is the magnification produced? So, they are saying concave mirror and they are not mentioning the nature of the mirror. So, we have to take both the cases. In case of real, suppose we are taking real image. So, what will come? Real image. In case of real image, so what will come? In case of real image, we have to take negative sign of this 10 and this positive sign of this 2. So what will come? M will come minus 10 upon minus 10 upon 2. So it will come minus 10 upon 2. So magnification will be minus 5 for real images. Okay. For real images, magnification will be negative 5. But for virtual images, it will be plus 5. I hope you understood well. I hope you are understanding. So we'll solve some more questions. Just look, have a look. See, I took one question. You can see this question. So we'll solve this question nicely. They're asking and converging mirror of focal length 20 centimeters. See, this is the focal length and converging lens. Converging lens, that means concave lens. So what will be the focal length of this lens? Sorry, converging mirror. Sorry to say converging mirror. I by mistake I said converging lens. Converging mirror giving focal length 20 centimeters will take f is equals to minus 20. Why I am taking minus 20? Because converging mirror, that means concave mirror. So this is minus 20 image which is two times the size of the object. Calculate two possible distances. So they are not saying, again they are not telling about the nature of the mirror. Sorry, nature of the image. I'll take for real images. So for real images, what will come? For real images, m will be negative. I'll take for real images. For real image. For real image, what will take? For real image, we'll take m equals to minus 2. Equals to minus 2. Equals to, they are telling it's a 2 times, no? 2 times, that means for real image minus 2. So we'll apply formula m equals to minus v upon u. So value of m is minus 2. We don't know about the v. So I'm writing v same, and I don't know about u. This negative sign, this cancel this negative sign. So v equals to twice of, it should be remembered, it is not 24, it is u. So we'll apply mirror formula. Mirror formula says that 1 by f equals to 1 by v plus 1 by u. Okay, so f is equals to what is the value of f is minus 20, and v value of v we are getting 2u, and this is plus 1 by u. So this is minus 1 by 20 almost. Question solved. So LCM will be 2u. See 2u. So 2u can divide by 2u. So what will come 1, and u cancels by u. So what will come here 2. Okay. I hope you understood this much. Right? I'll write. So you can understand well. So what will come? Minus 1 by 20 is equals to 3 upon 2u. After making cross multiplication, what will come? 2u is equals to minus 60. Okay, so u will be equal to, what's the value of u? Minus 30 centimeters. So automatically see, man, the sign of u is coming negative. It is the concept of concept of that means we can say it's a concept of sign convention, that u is coming automatically negative. I hope you understood well this question. And now similarly, now second part of the question, similarly when you will take u is m equals to plus 2 for virtual image, you know, for virtual image, please write virtual image. Here I will write in short virtual image. Okay, so m equals to, what will come? Again we will apply the formula m equals to minus v upon u. So value of m is 2, value of v we don't know, again value of u also we don't know. So what will come this time? V equals to minus 2u. Okay, again we'll apply the formula 1 by f equals to 1 by v plus 1 by u. Then again we'll apply the same value 1 by 20, and this time this v equals to minus 2u because we are getting the value, and this is 1 by u. Okay, understood? This is 1 only, my dear Bacha. This is only 1. Okay, after that, what we'll do? This is 1 by 20 minus 1 by 20, and we'll take the LCM of this 2u LCM. So this 2u cancels, so what will come? Minus 1, and plus this is again, you see this is the u only. I'm replacing this so that you can understand well. This is 1 by u. Okay, so this 2u cancel this 2u. So how many times? Minus 1 times, so minus 1, and u, so what? So this time what will come? 1 by u, that is 1 by 20. This 1 by 20 is equals to this 1 by 2u. But we are understanding this 2 minus 1, 1, and this 2u. So this 2u equals to minus 20, minus 20. So u is equals to minus 10. I hope you understood two positions. Minus 10, minus 10 is the value of. So it is very clearly mentioned calculate two possible distances. So I calculated all or both the possible distances. That means one possible distance will be minus 30 and second will be minus 10. Minus sign indicating we have to keep object in front of the mirror. It doesn't mean that means it is less than 0. Hope you understood well. Now next question is saying an object is held at 10-30 centimeter in front of convex mirror. Focal length. See this convex mirror and was converging mirror. Na? Convex mirror, so focal length is equals to what will the focal length? Focal length will be 15 centimeter. So the focal length will be positive. At what distance from the convex mirror should be placed a plane mirror to be held so that image in the two images coincide with each other. That means they are saying that suppose we are keeping convex mirror, so they are asking at what distance from the convex mirror should a plane mirror be held so that image is in the two images coincide with each other. That means in both the cases image will be, see what will happen. It is a convex mirror, image will be inside that means defined behind the mirror, and it's a plane mirror. In this way also image will be backside of the mirror. Okay, so what we are understanding that means object is held. So first of all I want to find out the position of the mirror image for this convex lens. So what we'll write 1 by f equals to 1 by v plus 1 by u. So here 1 by f, that means 1 by 15. Focal length is 15. 1 by 15 is equals to, we don't know about the position of image. I'm writing the same, but they are saying that object is held at 30 centimeters. So position of object is minus 30. Hope you understood. By 15, then this 30 will come this side, 1 by 30 plus 1 by 30. So this is 1 by, this is, by mistake I wrote this is v, u only. V. So v, and so now see what will be the LCM? LCM will be 30 will be LCM, and this 15 to 30 and 15, 30 and 30. So 1 by v. So it says that 3 by 30 equals to 1 by v. So that means v will be equals to 10 centimeter. We calculated the distance. We calculated already. So what we are knowing? We are knowing this image will form 10 centimeter behind this convex mirrors. So this is the position of image for convex mirror. So suppose we are keeping this plane mirror at, this is the plane mirror. Na? We are keeping the plane mirror at the distance of 10 centimeter. Okay, 10 centimeter. An object is already kept at 30 centimeter. 30 centimeter from where? 30 centimeter from the convex mirror. This is the 30 centimeter. So what will be the distance? This distance will be 20 of the object. So this plane mirror will form the image behind 20 centimeters. So see, this is a 20 centimeter. So the position, I hope you are understanding the of position of plane mirror. What is the position of plane mirror? Plane mirror will be at 10 centimeter from convex mirror. That means from this convex mirror, this is the convex mirror, and we'll keep 10 centimeter away from convex mirror. So see, automatically 10 plus 20, 30 centimeter. This is the object already, na? Object will be common for both the mirrors, na? So 20, 30, and this 20 centimeter, the object distance for plane mirror. So behind the mirror, it will form at the 20 centimeters. This is 10 already there, and this 10. So this image will be coincident for both the mirrors. I hope you understood well. Now we'll go ahead. So many questions are there. See, you can see some more questions, and out of these questions, we'll take some questions because all the questions, covering of all questions will not possible for me. I cannot cover all the questions. I'm giving some hints for you so that you can solve remaining questions. So here also I'll take some questions. You can see questions 11 to 16 are there. So I'll take some questions out of these questions, and I hope last two questions you understood well. If you understood all those two questions, all two questions, as we solved, as I solved on last that means page, so you can understand these all one also. Okay, so I'm taking. So please don't remain with me. So see, I'm taking one question. A 22.5 centimeter candle is placed 12 centimeter away from convex mirror. So I hope you are understanding convex mirror. This is the convex mirror I took, and this is polished from inside, and position of candle is 12 centimeters. See that, suppose this is the candle and this position is 12 centimeter, and focal length, what's the focal length? 30 is the focal length, and we want to know the focal length. Convex mirror is there, so focal length will be 30 positive. Okay, and position u is equals to minus, what's the value of u? Minus 12 centimeter. What we want to know by mirror formula, 1 by f is equals to 1 by v plus 1 by u. So focal length is already 1 by 30. Convex mirror is there, so focal length will be positive. Image distance we want to know, and plus 1 by minus 12. Okay, so this is 1 by 30 and equals to 1 by v and minus 1 by 12. So 1 by 30 and plus 1 by 12 equals to 1 by v. LCM of 30 and 12. What will be the LCM of 30 and 12? 60 will come. 12, 32 and 12 5 there. So 2 and plus 5. 12 5 is 60 and 1 by 12. 1 by b, sorry. So what will come? It will be 7 upon 60 equals to 1 by v. So v will be equals to 60 by, I hope you are understanding. V will be equal to 60 by 7 centimeter. Position of image. So we found the location of image, and magnification m equals to minus v upon u. V is equals to 60 by 7, negative sign same, and 7, and u is minus 12. Negative sign cancel this negative sign. 12 5 is 60. 5 by 7 is the magnification. That means value of m. I hope you understood these all questions nicely. See some more questions I'll take for you. One more question is there. An object. If you want to see all those questions for a long time, you just please see. And so many questions are there here for you only. So after completing this module, you will learn how to solve the numerical question. You can find one more video on the this same list and same playlist to understand more numerical questions separately. So see the question: an object is placed 18 centimeter in front of a mirror. If the image is found at a 4 centimeter to the right of the mirror, calculate its focal length. Is the mirror convex or concave? What is the nature of the image and what is the radius of curvature of the mirror? See, the question is that object is placed at 18 centimeter from the mirror. That means object is placed where 18 centimeter from the mirror, and if the image is formed 4 centimeter to the right of the mirror, see the right, so mirror will be mirror, this is the mirror. See, if we are keeping the object over here, see this is the distance of 18 centimeter, and they are saying the right side of the mirror, and they are saying just in 4 centimeter, distance of 4 centimeter. So what we have to understand, first of all, we'll take object distance is u is equals to minus 18, and they are seeing image is formed at right side of the mirror. So see both the cases in convex as well as concave. Both the mirror forms image right side, because concave mirror forms a virtual image in one case. So we are taking just this is v equals to 4 centimeter. On the basis of nature of focal length, we'll decide which type of mirror is this. 1 by f equals to 1 by v plus 1 by u. So v value of v is 1 by 4 only, and plus minus 1 by 18. This is 1 by 18. LCM will be 4 and 18. So LCM will be, what will be the LCM? LCM will be 36. 18 to the 36 and 9 4. 36 will be LCM. So 4 9 ja, and minus this minus. I hope you're understanding why we are taking minus. 1 by f. 1 by f equals to 7 by 36. What we are getting? We are getting positive focal length. So it will be convex length. Convex mirror, sorry. Type of mirror will be calculate the focal length. I calculated the focal length. Is the mirror is convex? So this is convex. And what is the nature of the image? Image will be virtual and erect. What is the radius of curvature? So double of this focal length, you can find the radius of curvature. That means r is equals to twice of f. So 72 upon 7 will be the radius of curvature. I hope you understood well, and we completed reflection nicely. Some more questions you will find here, and we can take some more questions. So let's see, last question I'm taking this one. Find the focal length of concave mirror produces 4 times real image. Again concave mirror and 4 times real. So m will be equals to minus 4. Okay. An object held 5 centimeter away from the mirror. So u is equals to minus 5. Magnification m equals to minus b upon u. Okay. So m equals to minus 4 equals to v, and this is minus 5, and this minus also, so minus minus cancel. This implies that v equals to minus 20 centimeter. Okay, so what we want to know? Focal length. So 1 by mirror formula, 1 by f equals to 1 by v plus 1 by u. So v we found, what was the value of v? 1 by 20. I'm writing directly minus 1 by 20, and here also this is minus 5. LCM will be, what will be LCM? 20 will be LCM. 1 minus 1 and minus 4. 1 by f. 1 by f equals to minus 5 by 20. So f equals to minus 4 centimeter. Hope you understood well and nicely.